Hello, y'all. I'm back doing some more linear algebra problems. Usually I'm on video for different types of videos. Usually I just have room for my pad and stuff here, but this is my image if you'd like to see me. And what we'll do today is continue our problems from the other day. We were doing some linear algebra problems. I did problem, uh, what was it? 10. I thought I did 8 as well. Maybe I labeled that one incorrectly. Uh, Suffices to say, we'll continue more problems. Maybe I'll go to 1.2. So let's take a look at the book more closely here and see what we're looking at. So, and make sure the first problem I did, I believe I did a warm-up problem to start. It was number 1. I just didn't write 1 there. And then we did number 10. So why don't we pick another problem, one more problem out of this section, and then we'll move to the next section, 1.2. Something that's similar to what we did in the homework. Okay, let's look at number 9. So it says, let P be the plane in R3 spanned by these two vectors U and V, passing through that point. Which of the following points lie on P? So let's check this out. So we have U equals 1, 1, 0. We have V equals 1, negative 1, 1. And the point that the plane is passing through is 3, 0, negative 2. So we know that the plane is basically this type of equation, right? So if we was to write this out, it'll end up being 3, 0, negative 2 plus S 1, 1, 0 plus T 1, negative 1, 1. And in order for it to be equivalent to the first point, so A is 4, negative 1, negative 1, that has to equal 4, negative 1, negative 1. So that means that S 1, 1, 0 plus T 1, negative 1, 1 equals, if I bring that to the other side, that'll be 1, negative 1, 1. Now I could already see that 1, negative 1, 1 is there. So if S equals 0 and T equals 1, then we know that A checks out. So B is the same process, except now we change the point that we're doing. So I'm going to just copy this down. And B is 7, negative 2, and 1. Should be that's C. So C is this. So same thing. S 1, 1, 0 plus T 1, negative 1, 1. And that's going to be 4, negative 2, 3. So now we have to solve this. We can try to solve it by, I forget the exact word my professor used. Maybe it was by inspection. Solve it by inspection. So what things can we do to equate? Now, one thing we see is that 0 is the last number here. So there's nothing I could do to multiply that to help out that 3. So we know t has to equal 3. T has to equal 3 because this last number here has to equal 3. So if t equals 3, that means we have S110 plus 3 uh, negative 1. Oh, and hold up. Oh, I have to change my number. So actually, I mixed this up. This has to be 0 because since this is 0, there's nothing that can detract from the 3 that's already there. And it has to equal 3. So I had that backwards. So really t equals 0 because anything I multiply times this 1 here is going to actually hold up. So t is a 1. Nothing I can multiply by that 0 will do anything. So t has to be 3 so that I can end up having 3, negative 1, 3 equals 4, negative 2, 3. So now I have my 3 there. So I'll highlight that. And what do we have next? So reminder for those who don't remember or who wasn't here the other day, I have a test on this stuff till Tuesday. So that's why I'm working it. So I'll work some of these on today and tomorrow and probably Tuesday as well. I'll just be earlier. So now I need to do something that makes given t equals 3. This is taken care of. The 1 here, the 0 is not going to be affected. So at this point, all I need to solve for is S11 plus 4, negative 2. Hold up, plus 3, negative 1 equals 4, negative 2, since the first number is solved for already. Nothing I do with S is going to change that 3. So what I have now is S11 equals 4, negative 2. So what can I multiply by S to give me that? Nothing. There's nothing I can multiply S by that'll give me uh one number that's going to equal that. Basically, this will be S equals negative 4 and S equals negative 2. Use positive 4. Yeah, so that's not going to work. So it seems like C is not part of it. So I'll make a check by A and the X by C. And this is a 9. So while we're at it, let's try B. So that will give me, and I'll actually start from here this time. And I'm going to bring that number to the other side. So when I bring uh, B is 1, negative 1, 1. So when I bring that to the other side of the original equation, basically the 1, negative 1, 1, I'm going to subtract 3, 0, and -2. So that's -2, -1, and 3. And let me actually make more steps so you can be clear about what I'm doing there. So used to hitting that part right there. So this is what we're looking at. So I'm just going to bring that to the other side. 1, 1, 0 plus t 1, -1, 1. That equals -2, -1, and 3, like we had before. So now I need to solve for this. So a little bit more complicated. By the same token, though, we know that this 3 over here is not going to affect anything. So perhaps we could still do the same thing and say t equals 3. So that means that S110 plus 3, -3, 3 equals -2, 1, 3. And when I realized I messed up on this part right here, should have brought this over. And I'm not sure why I guess they updated the, what's it called, where my delete is not where it usually is. So I should actually have S11 equals 1 and -1. Which still doesn't work. Now I have S equals 1 and S equals -1, which doesn't work. But it still is slightly different. So I have to remember that I need to bring this over. So it's actually S110 equals -5, 4, and 0. And still, this doesn't seem to work either. There's nothing that's going to make S equal -5 and S equal 4. So we'll say B doesn't work. So B and C don't work. So let's go to D, which is 5, 2, 0. They seem very fond of zeros. So now we have this again, our original plane. And now this has to equal 5, 2, and 0. So S110 equals plus T1, -1, 1 equals 2, 2, 2. Okay. So we know there's a 2 on the right side, so T has to equal 2. So we have S110 plus 2, -2, 2, 2, 2, 2. So now this 2 is taken care of. So now we just have to solve for S, and S equals, so bringing the 2 to the other side, that's 0 and 4. So it doesn't seem to work either. Let's take a look and see if I made a mistake on anything, and only A works. So this is 1.19. So it says A and C, yes. B and D, no. So I must have made a mistake on C. So let's see what I did. All right, so we have for C, 7, negative 2, 1. That's what it has to equal. We have 3, 0, negative 2, 1, 1, 0, 1, negative 1, 1. I bring that to the other side. This is going to be 7 minus 3, 4. Negative 2 minus 0 is 0. 1 plus 2 is 3. And I said that t equals 3 since it has to have a 3 for the third number. So that will leave me t equals 3, 3, negative 1, 3. And that's going to be S1, 1, 0. I'll mark in red what I'm changing. So the third number is taken care of. And that will end up being 1 and negative 1 still. So I'm not seeing what I'm doing wrong on this one. Let me think about it. Maybe I'm just jumping the gun by deciding that number is going to be 3. So why don't we solve this instead as a system of equations? I was able to do this one by inspection. So maybe what we need to do is make this into a matrix. So basically this is the same as 1, 1, 0, 1, negative 1, 1, st equals 4, negative 2, 3. So let's make putting that in matrix form. And let me expand the window size just in case. I'm going to expand much, but it might help some. And I'll expand the background book even though it's in the back, right? So this definitely uh, seems promising. And we know that the S and a T will uh, multiply improperly. So what I'll do is I'll go ahead and bring these over 1, 1, 0, 1, 1, 0, 1, negative 1, 1, and 4, negative 2, 3. Right, so let's see if we can solve this matrix. And I'm actually trying to solve for S and T, which I should have one free variable out of the matrix. So let's see how this goes. So if I add row 2 plus row 3 equals row 2, That becomes, the first row stays the same. Uh, row 2 plus row 3 equals row 2. 1 plus 0 is 1. Negative 1 plus 1 is 0. Negative 2 plus 3 is 1. And then 0, 1, 3. And we can swap rows. So I'll just do 1, 0, 1, 0, 1, 3, and 1, 1, 4. So all I did was move this row up, move this row up, and move this row down to the bottom. So row 2 became row 1, row 3 became row 2, and row 1 became row 3. So that should be a legal operation. And then we have row 3 minus row 1 minus row 3 equals row uh, 3. There should be a 2. So row 3 minus row 1. So that's minus 1 and minus 1. And minus row 2, that's minus 1 and minus 3 equals row 3. So that becomes 1, 0, 1 and 0, 1, 3 and 0, 0, 0, which works out. So that means that S equals 1 and T equals 3. So I did have T equals 3. So I'm not sure why I set my T to equal 3. I must have did something wrong with a sign somewhere or something. Not sure what I did. But it was a good idea to configure the T to be 3. But I guess just solving for that part of it does not work. So I guess it's the rule of thumb. You have to solve the entire system as a whole to make sure the signs work out. So that's good to know. If we get a problem like this on the test on Tuesday. So that means that C actually does work just like the book says. So let's go ahead and jump to section 1.2. And we'll get some problems there. I'll do the same thing on this screen and expand things a bit. All right. And be sure, by the way, like the video, subscribe to the channel, and be sure to join my Discord. We can talk about science and math and all that good stuff. So we go to 1.2. Let's pick some problems from here. So let's get some warm-up problems in. So this is 1.1. Six, 16. And now we'll go to 1.2. So it's a nice little warm-up. Let's start with 1. For each of these pairs of vectors, x, y, and for each of these pair of vectors, x and y, calculate x dot y and the angle theta between the vectors. So we know that x dot y is x1, x2 dot x3, oops, y1, y2 equals x1, y1 plus x2, y2. We also know that x dot y equals the magnitude of x, the magnitude of y, cosine of theta. So we can say that x dot y divided by the magnitude of x and the magnitude of y equals cosine of theta. So that means theta equals cosine inverse of x dot y over the magnitude of x and the magnitude of y. All right? So that's that. And so this should be easy enough to figure everything out. So we'll start with the dot product. Let's go with A. Actually, let's go with G. We'll pick the hardest one. So x equals 1, 1, 1, 1. Y equals 1, -3, -1, 5. So x dot y is going to equal 1 times 1 plus 1 times -3 plus 1 times -1 plus 1 times 5 equals 1 minus 3 minus 1 plus 5, which equals what? 5 minus 4 plus 1, so that should be 2. 5 minus 4 is 1, plus 1 is 2. So theta equals cosine -1 of 2 divided by the magnitude of x is square root of 1 squared plus 1 squared plus 1 squared plus 1 squared. And the magnitude of y is 1 squared plus -3 squared, which is 9, plus -1 squared, which is 1, plus 5 squared, which is 25. So that equals cosine inverse of 2 divided by square root of 4 is 2 times 25, 35, 36. Square root of 36 is 6. So that equals cosine inverse 2 divided by 12 is 1 over 6. And I should know this, uh, but let's go ahead and work out the uh, unit circle. So we have 3 of these up in here. And we know that cosine of 0 is 1 and sine of 0 is 0. And we know that cosine of pi over 2 is 0 and sine of pi over 2 is 1. So you can write these out. So this will increase to 1. So we have 1 over square root of 3. Oh, not remembering. Hold up. Oh, okay. This is square root of 3 over 2, square root of 2 over 2, and 1 over 2. And this is square root of 3 over 2. This is square root of 2 over 2. And this is 1 over 2. And this would be 0 degrees, 90 degrees, and 45, 30, and 60. Um, Still not ringing the bell with the power over 6. So I guess it's not an even unit number value, but it seems like it should be. Usually these problems are cosine inverse 1 over 6. All right, I'm going to use my calculator. And oh, sorry I didn't swap over on my pad that time. This is the math I did. It says 1.4 radians. Let's see what this is in degrees. It says 80 degrees. This makes sense. Pi over 2 would be here, which is 1/2 of 3.14, which is about 1.57. So, I mean, the value makes sense. It's an odd angle, perhaps because I have to remember that this is a 4. This is an R4, so this stands to reason it'll be something weird. But I'm sure that's how that's done though. So let's see what else we can find. 16 is interesting. 6 says suppose X and Y are in Rn. The magnitude of X equals 3. The magnitude of Y equals 2. And the angle theta between them equals cosine inverse of negative 1 over 6. It's interesting. It should be exactly what we had the last problem, except it's a negative value. I have to remember that this is number. So really the first one I had was here, and the negative one is here. It's like on the other side, it looks like. That's what it's looking like, right? So show that those vectors are orthogonal. Okay. So if vectors are orthogonal, that means that, so like for instance, if X and Y is orthogonal, then their dot product equals 0. So if these two are orthogonal, that means that X plus 2Y dot product X minus Y equals 0 if they're orthogonal. So let's see what we can do here. We could simplify this and say X 2Y minus Y equals 0. Because the dot product is distributive. Or maybe I did that distribution wrong. Let me think about this for a second. Oh, no, this is not the place for that. I would need to have a negative in between two dot products. So I'm thinking about something different. Like if I had x dot y minus uh w dot z. No, no, x dot z. And that'll be the same thing as x dot y minus z. Am I thinking about that correctly? See if I can find that theorem or whatever it was. So to make sure I'm remembering this property correctly. Okay, so this is the one I was thinking about right here. Yep, so there has to be a plus sign in between them, not a dot product. So that's a difference. There's two dot products with a sum between them, but here I have two sums with a dot product between them, so that doesn't work with this. All right, so good to keep that clear. The theorem or the law, whatever it is, only works if there is a sum between two dot products, not a dot product between two sums. All right, so it's good to keep in mind. Too far. There we go. So I'm showing these two are orthogonal. So the dot product between these is 0. So let's see what else we can do. We have x1, x2 plus 2, y1, 2y2, dot product x1, x2 minus y1, y2. Okay, so we have that. So we have x1 minus 2y1, x2 minus 2y2, dot product x1 minus y1, x2 minus y2 equals 0. So this means that x1 minus 2y1 times x1 minus y1 plus x2 minus 2y2, x2 minus y2 equals 0. So this is x1 squared minus x1 y1 minus 2x1 y1. So that's 3x1 y1 plus 2y1 squared plus x2 squared minus x2 y2 minus 2x2 y2. So that's 3x2 y2 plus 2y2 squared equals 0. So let's see if anything cancels out. Doesn't look like it. And this is a x. So now we have x1 squared plus x2 squared. Let's see where they're going. So I have these pulled out minus 3 x1 y1 plus x2 y2. So I have these two pulled out, plus 2 y1 squared plus y2 squared equals 0. So x1 squared plus y1 squared, that's x dot x minus 3x dot y plus 2y dot y equals 0. So this is the magnitude of x squared. We're not going to actually add another step. And I guess technically it's not adding another step. It's just recognizing that the magnitude of x is going to be x, the square root of x squared plus y squared. So since there's no square root over it, I squared that whole thing. So this is the magnitude of x squared minus 3x dot y plus 2 magnitude of y squared equals 0. And they gave us the magnitude of x and the magnitude of y. So the magnitude of x squared is 3 squared minus 3x dot y plus 2 times 2 squared equals 0, because it is the magnitude squared. So we have 9 minus 3x dot y, those are vectors, plus 2 times 4 is 8 equals 0. So we have 17 minus 3x dot y equals 0. So now we have 3x dot y equals 17. So x dot y equals 17 over 3. Oh, I see. And we know that that's going to be the magnitude of x, magnitude of y, cosine of theta equals 17 over 3. And the magnitude of x is 3. The magnitude of y is 2. So 3, 2 cosine theta equals 17 over 3. So I need to multiply both sides by, divide both sides by 6. So that means that cosine of theta equals 17 over 18. So theta equals cosine inverse 17 over 18. And it said theta, well, hold up. Theta is the arcsine of negative pi over 6. So that means that's cosine of cosine inverse of negative 1 over 6 equals 17 over 18. Right, so I did some math or something incorrect up in here somewhere. Let's see what I did. I think the general idea is right. Got to be orthogonal, so the dot product is 0. So x plus 2y, dot product x minus y, the dot product has to equal 0 if they're orthogonal. So x uh, 2 y1, y2 minus x minus y. So x minus 2y1, x2 minus 2y2. Also 2 is distributed. And x1 minus y1, x2 minus y2. The dot product, multiply the first ones and add. This one, that's good. This one squared minus x1, y1 minus 2x1, y1 is minus 3x1, y1 plus 2y1 squared plus x squared 2 minus x2, y2 minus 2x2, y2, that's minus 3x2, y2 plus 2y2 squared, that looks right. So now we have x1 squared plus x2 squared, that's the magnitude of x squared, minus 3x1, y1 plus x2, y2, that looks good, plus 2y1 squared plus y2 squared, so that's the magnitude of x squared, 3 of that. Oh, I see. Oh, no, that's all right. Thought I might have added an extra 2, but that looks fine. Magnitude of x is 3, so that's 3 squared. Magnitude of y is 2, so that's 2 squared. 8, 9, 17. Everything looks right. The magnitudes 3 and 2 divided by 6. 17 over 18. Well, I'm not sure what I did wrong on this one. Let's see what they say in the answers. Okay, so the idea was right, that x dot y equals that. They said equals -1. Hmm. So the question is, why does x dot y cosine theta equal -1? So let's test this out. We have 3 times 2 cosine of cosine inverse -1/6 equals 3, 2 cosine of -1/6 is 9.95 times 10 to the 1 degrees. And cosine of that, oh my gosh, I see, is 3, 2 times -1/6. So that does equal -1. Everything seems right. I had the 6 multiplied in front, so if I didn't divide the 6 out, I would have gotten -1. So why is my right side not equaling the proper value is what the problem is. Perhaps I left off a negative somewhere. But it seems what I have to do is start with this, that magnitude of x, magnitude of y, cosine theta equals 1. And then should be -1. And then, okay, so it looks like I got that part right. Oh, but right here they don't have the -3. Let me see why. They have the magnitude of x squared minus x dot y with no 3. That's a bit ahead. Magnitude of x squared. They do have they have 2xy. Well, this is the 2 magnitude of x squared. So it looks like the middle part is what's different on mine. So let's try to figure out how. Oh my gosh, I see what I did. I threw a negative here by mistake. This would be plus. So that's the error I made. Guess I was looking at the negative on the other side and I threw a negative here by mistake. So this would have been a plus and this would have been a plus. So then I would have x1 squared. That would still been right. The minus that. That would have been plus 2. So that would have been 1. And then minus 2 there. And then it would have been plus x squared. Minus and plus. So that would have left 1 uh, uh, plus. And then it would have been again minus this. And that's how I would have ended up with the x squared is still fine. This still comes here. The y instead would be -2, which is what they have there. And this would have been positive. 3 would be gone. And this would be positive. So then I would still have 3 squared, 2 squared, 17. This would be 17 plus that. So this will be minus 17. Right, so there's still something I did wrong. Let's see what else it is. So if this is negative 1, so I guess this is the part I'm missing. Why does the whole thing equal negative 1? Okay, that's right. This would be negative 6 times with that, so that's negative 1. So I'm still missing a negative somewhere. Okay, that's where I said I forgot to correct this negative here. This would be negative 8. So this would be 1 plus, so it does equal negative 1. Negative 1. And we know this whole thing equals negative 1 from calculating it out. So this equals negative 1. This whole thing equals negative 1. So since negative 1 equals negative 1, they must be orthogonal because all the numbers check out. Right. So gotta watch the signs closely. I am sleepy. Uh, so thanks for watching. Those who watch in the future, and I'll be back tomorrow to do some more of this math, probably immediately after my my physics lab. I have a physics lab in the morning, and then after that, I'll come back and work on some of these problems. So, as far as I'm aware, I don't have any math homework due. Uh, so I better not. See here. I should have some time to do all of these things tomorrow. Right? Looks like everything is pushed back, so that's good. And I'll be back tomorrow. Spending a lot of time working these problems to prepare for my test on Tuesday. And I'll look forward to making 100 on that test. And so come back tomorrow and we'll work on some more of these problems.